Assalamualaikum, nampak tak slide saya?
Waalaikumsalam.
Nampak tak slide saya?
Nampak. Sebab hari
Okey.
Comparison belum lagi.
Yang ni kan kita habis tu kat sini kan?
Sebenarnya kalau yang apa tu solution Rust and Fall tu rasa doktor dah terangkan yang itu. Cuma doktor tak refer yang table kat sini lah. Tapi kan doktor nak kalau doktor nak ikut sini pun okey juga.
Alright. So let's continue our study about CEG 452 engineering survey. So everybody okay? Assalamualaikum semua. Everybody okay?
Okay, Doctor.
Okay.
That's good. That's good. Alright. So because we have two comparison between height of collimation HOC. Recap for you, rise and fall. You remember rise and fall? We have we record backside minus intermediate side. So either you get rise or fall. If rise, we put it positive. Still remember that. And if fall, we put it negative sign. Still remember that. And HOC, we calculate based on 2 points, and then we plus with the benchmark. Okay, so this we call it, when you see this two one, you can see that HOC is quite confusing, but very simple. Rise and fall is very easy to calculate because you can have sign plus or minus, but it's laborious to calculate. It means that you have many steps. Okay, let go, we call it by way one. We compare it. So normally in if you have final exam, this is the one of the popular questions. One of the popular question. So you must focus this one. Maybe is will be raised up in your continuous assessment because you don't have any final anymore. Okay, number one, HOC is faster to calculate. It's very faster. You mean that it's not time consuming. And if compare it to rise and fall, it's laborious to calculate because we have step by step, step by step. But this step is not confusing. And then involve fewer calculation. Okay, and this one is involved with more calculation. Alright. So the third one, no check on reduced level of intermediate point. Example, rise or fall. Because we're using HOC, right? So remember, right? But for rise and fall, we check on reduced level of intermediate points. Okay? I think you still remember that. Number 4, errors. So in error in intermediate cannot be detected. Okay, for the intermediate. Right, but error in intermediate can be detected. Is it correlated? Because we calculate all the intermediate points. And number 5, for HOC, to check on accuracy. So you still remember that the total number of your backside reading, you minus with the total number of the foresight reading, final reduced level minus we call it first reduced level. We call it 2 checks. And this way we have 3 checks because we also check about how many rise, how many fall. So I mean that in terms of checking, rise and fall give you more checking, more rigorous, more accurate. Alright. Number 6, suitable for longitudinal leveling, a number of intermediate site. Mean that For longitudinal leveling, for example, that we want to build out a road sections, okay? So we don't have many intermediate site. So we're using HOC calculation. And for Rust and Fall, suitable for fly leveling, no intermediate site. So sometimes this one is involved with grade contouring. Okay, for example, for grade contouring. Okay, so this is two comparisons between HOC and Rise and Fall, and you can see you can see that these two methods have, we call it, advantage and disadvantage. So far, is it okay, clear? Is it okay?
Okay, Doktor.
Okay, all right. So this is one of the issue, we call it leveling with misclosure. Misclosure corrections can be applied if leveling is start and finish at known reduced level, error is within permissible limit. For example, that you start from this point, excuse me, you start from this point, let's say it's point A. You know that point is 100. So you are doing, we call leveling, going to point B, going to point C, going to point D, E, F, and coming back to point A. I'm very sorry. Excuse me, Still remember, I repeat, you start from point A, the value is 100. What the value is, reduced level, or we call it temporary benchmark, or we call it benchmark value 100. And you do a survey going to B, C, D, E, F, and going back to A. If you're going back to A, you must close with 100. You start with 100, you must finish your calculation at 100. So you get the class? But sometimes you cannot get 100. Maybe you get 99.98. So we call it, this one is error. But this error, we cannot avoid. We must eliminate, or we have error but with a permissible limit, that you have error but acceptable error. Okay, for this one, you know, you start from your survey from this point, maybe 100, and you know this one, the value is finished at 19.00 meter. This one 100, this one 19. Because this one already established. You get these two value from Jabatan Ukur dan Pemetaan Malaysia. But you are from A, you're going to do a survey at point B, C, D, E, and F. It should be this F value is 19.00 meter. But sometimes you cannot get it. Maybe you get 92 or you get 89.73, for example. So this is what we call it misclosure. And misclosure is the error. And error, sometimes we can have a permissible limit. And if you have a big error, the survey must be conducted again. The survey must be conducted again. Alright? Good. Okay, this one is one of example about leveling misclosure. Okay, then we call it backside, they have intermediate side, foresight, HOC, they already calculated already, reduced level, distance, nodes, and they're doing arithmetical checking, sum of backside minus sum of foresight, 3.42, minus 2.231, so we get 1.219. and final reduced level minus with first reduced level, you also get 1.219. So missed closure, final reduced level minus final reduced level, this one, 99.97 minus benchmark 2. It should be benchmark 2 99.97, but you get 99.979. So you have surplus about 0.009. Okay, this one you can see, this one is error, So you get 0.09 meter, or we call it the error is 9 mm. Mean that you exceed 9 mm. It should be 99.97, but you get your final level 99.979. You exceed 9 mm, or we call it 0.009 meter when you minus final reduced level minus benchmark 2. Okay, final reduced level minus benchmark 2. So you get 9 mm. So why we get this 9 mm? We have many contribution. For example, that we observe not really in the horizontal reading about your crosshair. Your stuff, maybe you not put it in vertical. Maybe your equipment is not level. Okay, so this is all the result affected the misclosure or error. Okay, so 9 mm. So if you can, that this is one of rules, maximum permissible third order leveling. If you do, we call it something like contour, we're using this one, third order leveling is equal to formula, it's very easy, plus minus twice. So square root of d. D is the distance. You can see that the total number distance is 99. You start from 0, 20, 40, you pull your tape, still remember on side 50, 70, 80, and 99. So this one should be 99D, the total number of your length. Okay, so plus minus twice is a fixed formula, and square root of 0.099. So you get the permissible error is plus minus 3.776 mm for maximum permissible third order leveling. Okay, now you compare 9 mm and 3.776 mm. So leveling work has to be redone because it is beyond permissible error. Mean that your error is exceed than maximum permissible error. So this is allowable, mean that we can give you a certain error, you can meet error, but for this survey, so because your distance is only 0.099 meter, so it mean that you we call it we call it this value almost 4 mm, 3.776 mm to become your permissible error. Unluckily, your site give you 9 mm. So what we do? You must redo this survey. So engineer, you must check this one because most of engineer will not check this one. Okay, but if you don't have benchmark for number 2, or we call it benchmark number 2, if you don't have, it's okay. You just copy this one, put it this one at benchmark 0.2 99.97. But if you know your benchmark 2 is 99.97, you must check your maximum permissible third order leveling. Okay, so do you get this slide? Mean that is a control survey. You, after your, we call it your works, you must make sure your team survey give you this result and you check. Either the survey is a rubbish in or rubbish out, or this is we call it is good one. So one of that, rather than arithmetical checking, is to check your final reduced level and your benchmark. Okay ke?
Doktor,
Ya.
Azam dia tak boleh masuk.
Okey. Azam Okey dah, saya dah okey dah. Saya dah admit dah. Azam dengan Syafi'i. Okey, Azam dengan Syafi'i okey. Kita balik pada slide ni. Do you have any question about this slide? And this is really important because you as a civil engineer, you must control this one. You must check this one. Either you want to reject the survey works or you want to accept it. Okay? This is one of the best method to check the quality of your survey work, especially for leveling. So you must remember, as engineer, you must check this one, arithmetical checking and maximum permissible third order leveling, or we call it misclosure or error. So any question on this before I'm going to next slide? No question So far so good
Okay, Doktor.
Yeah. Okay. Okay. So this is another formula you must put in. If your client say, because sometimes you do a precise leveling. For example, precise leveling for what? You are doing something like railway track. You know railway track? Everybody, you know the railway track?
Yes.
Yeah. The railway tracks, the leveling must be precise. So they're using this one, first order rules. So it's almost 1 to 25,000. Mean that this one, you can make error. You can make error 1 in 25,000 data or in 25,000 length. So that is the means. So for the second order, 1 is to 10,000, mean that in 10,000 you have to have a chance to do just one error. Mean that if you measure, we call it 10,000 meter, so your error 1 meter, yes, it's a second order. If you measure 25,000 meter, so you error only 1 meter, so we call it first order. And the third order, you measure 5,000, okay, leveling, or we call it distance, so you make error just 1 meter. This is allowable. If you doing a survey 25,000 meter, but your error is 0.5, so it's good. But if you are measure 25,000, your error is 2, you are not in the first order, you are maybe going to the second order or third order. So is it okay, class? First horizontal relative accuracy between directly connected points. Okay ke? Right. Normally your client will give you which order they want it based on the project. Okay, which order they want it. They will put it in the document contracts or in the BQ, or maybe we call it additional addendum. They put it in your contract works. Okay, so you must particular on this and make sure your team works with this accuracy. Unless if you cannot achieve this one, your client will reject your works. So mean that you have your project, you have your teams, but you do something like unquality work. So the client reject, you must redo. Okay. So this one is horizontal. Horizontal mean that is 25,000 meter of length. that you measure. 10,000 kilometer of length you measure. 5,000 meter. Okay, so this one in horizontal. But in vertical, you remember that we already discussed what this one, third order, 12 mm, 0.05 feet. Okay, alright. So this one is vertical, mean that is we call it your leveling survey. Your leveling survey. So you have first order, second order, and third order. If the lecturer or your client want you to calculate first order, you must comply this one. Okay. So first order is equal to 4 mm or 0.01.7 feet. MM is empirical, feet is we call it, MM is symmetric, okay, feet is empirical, you time by the square root of D. D is length of section in kilometer. Normally we measure in a survey the length in meter. So when we go into kilometer, we must divide it with 1,000 because kilo is 1,000. Okay. So second order is 8.4 mm. Remember this one 4 mm only. So this one 8.4 mm. Okay. Times by square root D. Square root D is same. Length of the section in kilometer. But you look at the value is different. Why? You can make 4 mm error and this one you can make 8.4 mm error, but the order is different. This one is first order, this one is second order. Mean that the more you doing your error, your order become going down. Okay. For third order, the same formula. We just change this one, 12 mm, okay, or 0.05 feet times square root of D. And you must remember, D must be calculated in kilometer. Okay. Let me admit your friends. Okay. Okay, now we have full class. It's very good.
Doktor, Arif nak masuk.
Dah, saya dah approve dah. Dapat tak?
Okay.
Dapat tak? Dapat sebab saya tengok ada 13 dah Okay. So, who give this order? So we call it in Malaysia a lembaga. We call it lembaga juru ukur tanah. They will give you what kind of project, what order. They give this order, and if they give it first order, mean that 4 mm times square root of your length of section in kilometer. Okay, so D is for the horizontal, D is for vertical. Vertical for your leveling. This one for your leveling. This one for your distance. This one for your distance measurement. Okay, alright. So D is the formula to control your work, to make sure your work on site, your work on field is high quality according to standard and what the surveyor or your client want. Okay, right. We're going to slide 41. Let's say in example 3.4, the error is within permissible limit, then corrected could be done. See example 3.4. Okay. So now, sometimes after you finish this one, you check your leveling misclosure have a problems. So how we want to counter the leveling misclosure? So first, we have two additional column. One we call it correction, one is correction of reduced level. Okay, we doing something that we want to make sure final reduced level and benchmark point 2 is same or less. Is same or less. And you must remember, this correction must be within the limit. But our example is not, we call it meet the criteria, but we using the example to do the correction. So this correction is not good practice on industry, but for purpose, academic purpose, it's okay. Okay, so number one, write reduced level of the first and the last benchmark in corrected reduced level column. So you copy this one, 98.760, you copy to this column in correction reduced level, and you copy this one, 99.97, to the column correction of reduced level, because this two value is fit actually. Okay, this one is we call it fixed already. So after you copy, what we do? Okay, next slide 44, right? So we already calculate misclosure. Still remember that the previous one in the last row, 99.970, this one. So you minus this one, 99.970. So 99.970 you minus with 99.979, so you get 0.09. We already calculate. So you take this value, you put it as a negative in the corrections, and you must remember you bring your negative. Why you bring your negative? Because if final reduced level 99.979, you minus with 0.009, so you get 99.970. It's same. That is our main goal. That is our main goal, right? Okay, next, what we should do? Okay, so for the rest, what we should fill up? You can see that the question mark 1, question mark at point B, question mark point C, point D, point E until F. Right. Calculate correlation for others row using this formula. So using the formula, then the formula, what the formula said is correction is equal to misclosure divided by number of setup equipments times by loop number. I repeat, correction, because this value we should fill up at the question marks place for the station A, B, C, D, E, and F, right? Correction again equal to misclosure divided by number of setup equipments times loop number. Okay, so now we get this value, and the first correction we put no correction, or put it negative or positive 0.00000. How we get negative 0.05? Okay, for example like this. First loop 0.009. Okay, this one take this value okay, divided 2 times 1. Okay, so equal to 0.001. What is 2? What is 1? 2 is number of setup equipment. Okay, times by loop number. Okay, so you can see the blue color. Mean that you remember that this one is backside, this one going to intermediate side, intermediate side going to the intermediate side, intermediate side is going to intermediate side, intermediate side going to the front side. Mean that this one is the first loop. Okay, first series of the survey. Okay, all right. So you get 0.005. So all the value here, 1, A, B, C, D, D, you replace with the 0.005. Negative 0.05, negative 0.05, negative 0.05, negative 0.05. Finish. Okay. Now we go for green color. Green color is second loop. You take the total error 0.009, this value. You divide it by 2, you times by 2 is equal to 0.009. Why we time 2? This one we time 1. Because this one is first loop, this one is the second loop. Because we start from back side, intermediate side, and going to foreside. If the survey continue, you can say that you divide it by 3 because you have the set of data. Maybe third loop, fourth loop, okay? So 0.09, you copy with the rest, the remaining, station E and F. So what we do after this is very easy. 97.477 minus 0.005. So you write your answer here for point A. And for point B, 98.415 minus 0.005. So you get 98.410, this one, for point B. And you do all the rest for point C, B, E, and F. Okay? So that is, we call it your answer. Okay? That is your answer. Okay? Finally, calculate corrected reduced level. Okay? Finally, calculate corrected reduced level. So you get all this value, Okay? Alright. So, the example about missing leveling data. Yeah, you can see that if you have the missing data, for example, intermediate site here, we miss. We miss also, we call it intermediate site at point B. We miss data about intermediate site at point C. And we miss a data at intermediate site at point D. How we get all this value? Because if you have this, so for sure rise and fall and reduce level or your notes is finished, is easy because we start with raw data. So how we want to trace back? For example, that point A, to find A is a minus 1.264 equal to 1.057. This one. Okay, mean that this value point A, you minus with intermediate side 1.264, so you can get rise 1.057. Okay, so mean that A is equal to 2.321 because this one is rise, so we should be positive, right? So this one is value is more than this value, so you just plus 1.057 plus 1.264, so you get point A 2.321. It's very easy. How you get find point B? Point B, you can see this one, how you can correlate this value 1.264, of course minus B, so you can get 0.271. So because this one going to fall, you know that B value is bigger, so you just plus 1.264 plus 0.271, so you get 1.535 for point B. Okay, so this is how we calculate. Okay, how we want, we call it to calculate, for example, that point E. Okay, point E either rise or fall because we don't know A before this, right? Now we already know 2.321, so you just 2.436 minus 2.321, so you get plus 0.114. So you fill up this one you erase. So this is how we want to refine if our data is erased, or maybe we call it the data is missing. Okay, so this is the source of error. When you are doing a survey, you must aware that you have make it error. So one of that is like this. Actually, you must read straight, but you are read using, we call it normally bottom stadia. Okay, bottom stadia. You we call it doing misreading about your reading. It should be, you still remember that we have circles, right? And then we have vertical crosshair and horizontal crosshair. So the horizontal crosshair must be here. It's not here. Here, this one is you read at the lower horizontal collimation line. Okay, so this is one of the error. Okay, second error, collimation error, line of sight, not horizontal. Correct reading, size of error depend on sight line. This one is actual reading. So mean that if the stuff you put here or you put here, what is the difference? Mean that if you read the false error here, the distance is far from the original one, so you can see that the gap of error is bigger. The gap of error is bigger. For example, that you measure 10 meter and then you measure 20 meter. With your first reading, 20 meter distance give or contribute more error. Okay, so this one you must aware when you take a reading. So you must aware these two process. Okay. Now we are going to slide 51. Error in the equipment. You have we call it you have equipments and you have error. Number one, we call it collimation error. Line of sight not horizontal. So how this happen? Normally your telescope, still remember that your leveling equipments. So when you are doing centering, sometimes you are become lose your grip to the leveling instruments. Mean that the instrument fall down and it affected the horizontal. You see the physical one is okay, but line of sight, or we call it collimation line, in the telescope is already gone. So you must send to the company to recalculate about the collimation error, because this one involved with the electronic engineer. So that's why every time you have accident with your equipment, you must report to the lecturer or your supervisor, and we should test either the collimation error is happening or not. Okay, the second one, keep sight length from each instrument position the same. Okay, mean that sometimes mean that sometimes we call it backside and we call it foresight. So backside you take 5 meter, and then we call it foresight also you take 5 meter. Mean that we try to make it same, constant. For example, that what we do is on your practical survey leveling, you set up, you still remember that on site you set up the grid system, maybe 5 meter time 5 meter, maybe 4 meter time 4 meter. So because we want to maintain the keep site line from each instrument point is the same. So this is one to eliminate error in the equipment. Okay. Third one is check collimation error using two-pack test. I think we already passed this one. 2 slides we already passed previous lecture. And then check prism is not stop every reading. Okay. For example, that's you remember that in telescope you have collimation line, and you also have, we call it, focusing screw. That focusing screw will relate with the prism. So either the prism they move it to forwards in the telescope or moving inwards to make sure that your line of sight is clear. Okay, so this prism, when you adjust it, your leveling instrument, for example, that focusing screw, you make sure that the prism is working. Either you turn it in front and then the prism move to front. Maybe you try to focusing your sight from near to far. So make sure that the prism is working. If not, we must send it to supplier to do the calibration. Another one is a parallax. So parallax normally is very easy. When you are doing, we call it leveling. Before you take the actual reading on stuff about your value of your height, okay, still remember that? You must make sure that you adjust your focusing screw until the line of parallax, the line of we call it crosshair is clear. Just we call it in one line. You cannot make it the line double. Mean that you must eliminate parallax. This one is very easy. You adjust, number one, your focusing screw or your eyepiece. Sometimes the student, they adjust only focusing screw, but they not adjust the eyepiece. So you cannot have a very clear crosshair. So before you read, make sure your crosshair is clear. Then you read the reading. So you eliminate the parallax. Okay, next. Focus eyepiece on crosshair, then focus telescope on staff. Okay, I think parallax and this one I already explained together. That's good. So we continue. So we also have the error in the equipment. Sometimes the students, sir, we already get the value, but our value is not satisfied. We still have, we call it, get the value in third order work, but sir want the first order works. So sometimes you must check either your stuff is error. So mean that you have, we call it, your aluminum stuff, and at your aluminum stuff, you have, we call it, indicated value, the height ones. One in the matrix, another one in the empiricals. So, zero error. Base may be wounds. Doesn't matter as long as same stuff is always used. Okay, mean that sometimes when you look at the leg of staff, you maybe you realize that sometimes they have shoes. We call it plastic shoes in the black one. So this because of we always using the staff, that leg made from plastics is we call it shredded. Is we call it tear off. So sometimes the leg of staff is not level. You must be careful. Okay? Or you have your staff, but it cannot be extended. Extended means what? Still remember that you pull it and then the staff stay, the sound like pang. Alright? So you must extend properly, mean that extend your staff in full and then take the reading. Unless you carry this one, error in the equipment. Okay, we continue. Reading and booking error. Reading and booking error is normally student makes many error because sometimes they are not serious on site. Sometimes you feel boring. Sometimes you are very tired because of weather. Sometimes now after this you have become, we call it engineer. You bring your, we call it your staff doing a leveling maybe for, we call it 3 months in the jungles. Sometimes your staff feel boring, unhappy, and this one contributing in the reading the stuff mean right, reading the values, and booking error mean that how you record. For example, that it should be backside because of boring you put foresight for them. Sometimes 1.35. Okay, so you write 1.53. So this is the error. So you must keep citing short to estimate on staff accurately. Because the staff, we are sometimes dealing with a millimeter, so don't put wrongly place on decimal point. For example, that 0.01 mm is not 0.001 mm. So you must be careful on this reading. So, and all readings, we call it takes. When you read your reading first, again, you read second reading. The same place, you must read twice. And you record clearly. And then after you finish your works, make sure that you are doing calculation to check either your works at that today, or mean that at that times, or we call it today works, is valid. Okay, sometimes it's involved with your accuracy based on weather. The wind cause level to vibrate. Sometimes it's a very heavy wind. So normally, in Europe, so when you study in Europe, you can see that it's a windy weather. And windy weather sometimes vibrate your leveling. You level your equipment, but when the wind come in, it will, we call it something like push your leveling instrument up. So means something like you vibrate. So at this point, you must stop your reading, your booking error, until the wind finish. You are doing again levelings to your leveling instruments, and then do the reading and booking again. Okay, this one is a common mistake by normally staffs. Okay, sometimes it's by students. Okay, misreading the stuff. For example, that 1.25 actually it's not 1.25, it's 0.25 meter. For example, moving turning points. Okay, Field notes mistake. Field note mistake something like, okay, read. The reading is 1.025. What you record? 1.250. Sometimes we miss your friend's sounds. Mistake with extended staff. Maybe your staff, excuse me, maybe the staff is not extended in full. And moving turning points, for example, like this, you still remember that in Malaysia we have a paddy field. Okay, so paddy field. So normally we call it the soil is clay. The soil is clay. For example, that one a big challenge is when you set up your equipment, either you put stuff on grounds or you put, we call it your triangulation, or we call it tripod on land. When you want to use after 50 minutes, you can see that your leveling instruments going to settle. Your stuff also going to settle. So this is one, make sure be careful when you are doing, we call it a leveling survey on paddy field, because the soil have a massive settlement behavior. This is example of the moving turning points. Okay, summary of leveling. We already learned about from the first slide until now. Actually, what is the summary? Okay, check tripod is on stable ground or dig fit well in. So make sure your tripod, when you want to set up, you set up on the stable ground. For example, that you want to do, we call it leveling on paddy field, or we call it in pit swamp. Pit swamp, you know that pit swamp? Kawasan berpaya, for example, Tanjung Piai. Okay? So what we do, if your point still moving, you must do first piling, you must pile your 3 points using maybe bakar pie, and then you set up your equipment on the bakar pie. If your ground is not stable, use pond bubbles to set appropriately vertical standing exist. Mean that if you have, we call it your stuff, we already give you another one. We call it pond bubbles, or we call it leveling. We call it leveling sets. You attach to the your stuff to make sure your stuff is in vertical and parallel 90 degree to ground. The third one, eliminate parallel every time we sight the stuff. Make sure that you focus your image very clear using number one, your eyepiece, number two, your focusing screw. Last from this slide, check that the compositor are functioning every time we sight the stuff. Okay. So normally this one is a compositor. Normally we dealing with a client. What we can do now, every time you are doing a sighting, for example, backside going to intermediate going to intermediate going to first side you change to the backside again. Make sure that when you reading before that, before you make sure you eliminate the parallels, make sure your image clear. Another thing, make sure your leveling instrument is level. Every time before you take the reading, make sure your bubble is level. Your bubble is level. Okay. At every instrument setup, always start with a backside to a point of known reduced level. Yes, this one we already practiced. So first thing we take as a backside as our first point, right? At every instrument setup, always finish with a foresight. This one we already practiced. Either the instrument move or the staff move, never both. Okay. So sometimes the instrument move, sometimes the staff move, sometimes the instrument error, sometimes the staff error, sometimes both error. Okay. So you must check your instrument before you take it or take out to the side. Always close leveling to a point of non-reduced level. Mean that if you start from your point A 100, you finish at point A going back to 100 because you want to calculate the validity of your data is right. So there is a end of part 2. I think we should we call it rest for 10 minutes. Okay, and then after 10 minutes we coming back to our business as usual. Is it okay, or do you have any question?